So if I'm talking about two levels, you have here this hatched one is the level of the top of the concrete, and then the other line is the top of the finished material. If you have the same thickness here, from the top of the concrete to the top of the finish, similar to here. This one is generic. I did not put layers in it, but you have to put layers. So that suppose now I'm having this is my top of the concrete. Let's say that I'm having this is my top of the concrete, and I have maybe 10 centimeters to express my finishes. If I have the same 10 centimeter maintained here, I don't have problem to lay the stair from the top of the concrete or the top of the finish to the top of the concrete or the top of the finish, because the distance is going to be the same. So that from top of the concrete to the top of the concrete for the following floor, if it's 3 meters, it's going to be the same from the top of the finish to the top of the finish if I am maintaining the same thicknesses of the finishes. So that I have to be careful about this. I have to be careful about the dimension, the height that I have. Like so here I want to fit. Just talk a little about the stairs, how you fit in the stair. So that suppose I have that, and I want to fit in a stair here, so that I can go. And by the way, the stair is not located in the structure, as I said, just pointed out that the stair is yes structural member, but it is not a structural member holding anything above it. It's just hold itself, and of course the people or the persons above it. So that's why it is in here. So that if you click on it, you will have, and pay attention please to this 100%. If you drop down the menu here, you will have 3 types: the assembled stair, and those are mainly steel, and then you have cast in place, and you have precast. I would go with this one, the monolithic stair, cast in place. Do not go with the precast, because we want to learn how this is attached to the building. We also want to avoid having the steel stair. You can do it steel stair in general in building, but let's stick to this because we will learn from this as much as we can. So that by taking that, of course, the properties at Revit here, or the guides will open up to us, telling us what is the base level, what is the top level, so that we are linking this level 1 to level 2. And of course, ask us about, here is the important thing about the dimensions. You need to go to the dimension and see what is the desired number. And suppose I will do similar to what I give you 20, and I would say the actual threads are 0.3. That is the thread that I have. It will correct itself by itself. The actual riser is going to be as 0.15. If I click apply, I still can go here and edit the type and of course duplicate if I want to do something, but make sure that it's cast in place and monolithic stair. You can adjust the riser height from here and thread depth from there. And you can also go to edit and use your own calculation, like what is the calculation that you want to have, the relation between the depth and the riser and the height. So this is the introduction about the stairs that we want to have. Usually when you come to here also, you want to draw it by offsetting, so that once you click here, it will offset from this line. What is the width of the run? You want to make it 1 meter. And here, of course, where is you are drafting your stair. So that suppose I want to draft it from the right, because I start from the right. I start here. Also, you can sketch, by the way. You can have different things. You can have free. You can have it as run like this, or you can have it arched stairs or U or L shape. But the good thing about that, it will calculate many things for you. So that if I click, and it gives me here that is about 3 meters. I have to ask, do I go 3 meters, because I have about 10 steps, and each one is 30, so that will give me 30 centimeters. But I have to pay attention to what width I am getting, so because that will define the landing for me as well from here. I stopped here. The stair did not finish because this is not defining the whole thing, so I can go here and start to run the rest. No matter how much I go, it will stop at 1 point. Why? Because the stair ends here. This is the how many stairs that I have. So this is what I have as stairs. Now the thing is, you see that this is a little bit overlapping the stair here. So that once you click, it will give you some question. So it will give you some of the problems because that is overlapping. So that I can move this a little like that. If I am done with this, I can hit the yes. It will give me something about the railway, the guard rail or the handrail here. Don't worry about this for now. We still have to think about one relationship that is in here. Here is you have 2 options. Either you connect the fly of the stair directly to the wall so that you don't have a gap, or you have a noticeable gap, so that by having 10 to 15 centimeters gap between the fly and the wall is not going to be something professional. You have to have at least 30 to 40 centimeters at least. Why? Because this place, if it's too small, it will trap dirt and it's not going to be accessible to clean. So that you have to make a clear gap between the stair and the wall, or you don't make. You just make it as if it's one slab continuous. That is one you have to pay attention to. The other thing that I want to share also with you is something that we talked about regarding the handrail here. I want to just click on the section that I have. You see this knee? This is what happens because I am going into, you see that neck that happened in the handrail or the guardrail in this case, because I'm not making my stairs very well. I have to, because here is at this level, I have this height, and at the same height in here, I have 2 levels actually. So that you have to push one with respect to the other one. So that you have to push this one step further or 1 step inside in order to make them not overlapping. So that in the plan, if you go there in order to avoid this necking, what you can do is that you go there, you see that this line is similar to this line, is the same, aligned with this line. Why? The handrail here is just going up, is necking like that and go up, and then you will continue because you want to maintain the same distance. And in here, this is not the same as this distance. So that you have to start that stair a little bit to inside, to this way, so that you start it from here or you start it from there. So that make the last step here, the starting step from the other fly is either before it or after it. Don't make it with the same, because that will make you that necking. And that necking, by the way, as I said, is not wrong, but at the same time, it's not preferable to have something like this in your building because it's going to be like a deficiency in your building. Now, the other thing also that we want to look at is if you look at this, see, because I define here cast in place concrete, it just directly hatch this for me. It makes it hatched like this. I prefer not to have this. I prefer to have my stairs coming up to this level, not to stay at this level. Why? Because the materials, the connection between this and that might be different materials. Now, pay attention with me. I might have a material here, like tile, like carpet for the second floor here. And this material is going to be different, so that the last riser that I have or the last landing that I have has to be from the same materials as the stair. So that if I make this connection like this, I don't know where is that finish of the where is the finish of my top. So that's why it's better to have the connection like this. If I, by the way, if you pick the whole stair, you pick the whole stair here, so that it gives you the option and the properties for the whole stair that we started with. If you go again and hold the tab, it will take the fly for you only. It says here stairs run to pick the run for you here, and you have several options here.
Do we take it up and we choose?
Yes, you can click tab. You see here, I click tab. I didn't choose. You see, click tab. Again, I pick the whole stair. Click one tab. You choose the run that you are on. So you have the option here. You see, so that if you hover over one thing and you have more than one option to pick, you can click tab and see. See here, I stop on the level and the stairs and the slab. If I click tab, it goes to the slab. If I click again, it goes to the level because they're overlapping in my drawing, so that it gives me the option to pick what I want to pick. So that if you pick this, you see that it gives you here what is the relative top, and do you want to begin with riser and end with riser or not? So that these are things you need to be careful about, because if you're not doing this properly, it will make things gives you some errors like this. And here is what's happening. I want to, instead of doing this, I can have my relative top more than these, so that I can say that let's make it 3.15. I'm giving you some options. Okay, let's go back here and let's make this 3.15 and then apply. You see that the stairs was extended to have this relationship. So this is my stair, and the last step in it is representing my stairs. But this might create some problems also for you. So you have to pay attention to these ones. Like, let's see also if I step in here and go to edit type of that stairs, and let's go here. It says here the run type is 150 meter depth, the landing type is 300 meters, and this function as an interior. You have right support and you have left support. This is mainly if you do have concrete steel, you can do this, and you have the stringer here or carriage. Those are the side of the stairs. So that if you go to what do you call it, steel stair, you might have this because you have the runs welded to sides of that stairs, and these are the stringers, and you can of course, adjust these if you want. Like, you have the option here in the threads. It's cast in place. Do you want to make threads? If you click yes, and you want to click yes for here, and while you're opening, hit the apply, you see that the threads start to create itself. You see that these are the materials, the finishing materials of the stairs that are happening, and that is happening if you are having different materials, especially if you're having kind of stone, and that is very common in stairs now to have kind of stone to cover the stairs. Epoxy also is one of the materials. I think building the research institute building are covering the stairs with epoxy. The building 21 is covering it with wood, and we also replaced the carpet recently with wood. I don't know if you were here or not, but we changed our stairs that connects the studio area with wooden top. So that commonly you will see also granite, you will see marble, and usually they have, you want to maintain 4 centimeters for this, so that this height for the thread is going to be 4 centimeters, and that is because of the abrasion. People, when they are used excessively the stairs, they keep abrading it. They keep they produce lots of frictions between their foot and these threads, and over time it's going to be subjected to abrasion. You see that the stairs lose a portion of its material, and from time to time they need to be leveled up. So that 4 centimeters is good to treat the surface and clean it up, and remove the uneven portion from time to time, so that they stick to 4 centimeters. You have also the options here. Do you want to make it slanted? If you make it slanted and you had this. It's slanting, it is going to make it tilting a little bit. Let's just hit OK. I want to just zoom in a little in order to have these comments. And pay attention, I picked the run in order to have this drop menu shown up for me. And also gives you what is the material of the thread, what is the thread riser. Also, you can come here and it will navigate you to the material thing that we already know, so that you can specify here the kind of marble, the kind of granite, similar to this, so that we don't need to go into this. Then it tells you about the thickness, the thread thickness. Is it going to be here? The default is 5. You can keep it as 5, or you can make it 4 centimeters. What is the profile of this? Do you want to make it C-shape, or you want to make it stair thread, so that you have that? If you hit apply, you see that it looks like steel here, so that don't make it like that. Let's keep it default, and that is the default one for the concrete. And then what is the nosing length? Do you want to make this length flying over the thread a little, over the riser? Yes. If so, you can make it as maybe 2 to 3 centimeters. If I hit apply, you see that this is the slanting. This is the slanting that I did, I think. This is the nosing length. That's why the slanting isn't there. If you unclick the slanting and then apply, you see that it corrected itself because you don't have slanting. Slanting is good for the exteriors if you're having rain and water, and if the water runs down, you don't want to, either you have a nosing or you have slanting, because the slanting will not make the water go in on the surface. It will fall if this is slanted to the inside. This is what we need to see. But here is another thing also we need to look for, if I still recall. Yes, this option. If you click on this, extend thread on the riser and apply. Right. Why is this correct? Because of the construction. Once you construct the stairs, they don't do the vertical risers first. They don't do the finish first. They do the horizontal one. So that once they do the horizontal one, they attach afterward the vertical one. That's why the risers are rested on the stairs, rested on the threads, not the other way around. The other way around was like this, and construction-wise, you cannot do it. You still can do it for sure, but it's not going to be correct, because you will see here a connection that doesn't make a sense, and it's going to trap water in it. And the correct way is to make the thread finish before making the riser finish, and it will look like this. Okay, so if I click OK, and I want to see at the end this, I want to see in all of our drawing this. Do not make assembled stairs. Do not make wooden stairs, or not wooden, I mean like precast. Because if you do precast, it's not going to work. All of the functions that we just talked about is not going to work similar to what we have just explained here. So because we're making cut here, that is what is cut, and the back one is an elevation, shown as an elevation. Of course, you can pick the guardrail or the handrail, and then you can edit the path for it, and then you can go to the plan and then edit the path if you want to extend it. If you want to extend this handrail inside your building, or if you have an opening, you can extend this handrail. Now, the connection also is something important that we have to talk about. This, how we treat the connection between the stairs and that. It doesn't make sense to have this as finished and the stairs is resting on it. Also think about the construction. What is done first? Usually the thing that is done first is almost connected, and you have to set this properly. Do you finish the slab and add materials to it before doing the stairs? No, you do the stairs while you are casting the concrete, and then after that you do the finishes. So that one of the good commands that we are working a lot in here is the join command. So you pick that, and you pick what you want to connect to it, so that it will open them up to each other and then fill this with concrete. So that this is the correct way to do it. You see that the concrete here is continuous. See here, if I click on here, you see that this is my thing that I say to avoid. You see that here is my last thread, last riser. And then the software consider that the top of the slab is the riser, is the thread top, because it's going to be the same. And that is also one of the other things that you have to worry about, is that this height of the thread is about 4 centimeters, as we said, because of the abrasion. But technically, in our slabs, it's 2 centimeters. Usually, the material, the finishing material is 2 centimeters. Even if you are sharing the same material, you will have differences here. You will have differences between the finish of the top of the stair and the finish of the top of the slab. So that what you do is that you, as I said, you can come to here and you don't want to end with riser and then apply, and that will you have to pay attention to this. To that you see here, this is not the same. Now the stairs are not reaching the top. So that if I take it and I would say let's go to 3 meters, apply. This will create the, you see that? The top of the stair is connected to exactly to the clean surface and the top of the slab, and at the same time the slab is separate from the stairs. That is how it should be. Pay attention that when I have that in the construction, I said do not end with riser. If you pick the whole stairs, you don't see this command. So that you have to pick the pay attention, because also some of you struggle with this. You click here and you don't see what I'm referring to. So that you have to pay attention that you pick the run by hitting the tab to pick this only, and then you will see different properties section here. And then all of the nosing and slanting and this are appearing in the run. It's not appearing in the stairs in general. So this how it looks like. And of course the stairs from here will have a beam that is holding it. And this beam, by the way, is not going to be the same level of the floors, because you will have here, if you have beams here, you will have a beam on that ground level, you have a beam on this first level, but you don't have a beam in here. So that's why you create a beam to host this landing that is in between the two floors. Okay, what else we want to discuss? Of course, you have to open the void, because this is my stairs. What you can do is that you can make a shaft in your building, similar to the shaft that we have in walls. This is vertical walls, but here is a shaft. And then you have to go to which view that you want to have. And of course, you can run it maybe from here, or run it where you stop your riser. You have to make this in a judgmental way and not to make a mistake in opening your shaft. So this is our shaft. If you want to extend it, or so that you don't have to, like when you get to the level of the roof, don't expand this in it, because if you expand this in it, it will make opening no matter what you draw, it's not going to show. So that you have to stop it right below the what they call it, annex entrance, or these the stairs of that. So that this is now cleaning up the void for the stair, and they call it the stair room, or the stair void, in order to accommodate our stairs in it like this. So one of the things also that is like when they look at the drawing, they might say this is a professional architect or a professional detailer who did this, because you would see that this line, the bottom here and the bottom there, and this meets at one point. You see that here it's not, because of this issue that I told you about, that the stairs are not the same. So that the bottom here and the bottom there and the bottom here should meet at one point, and you extend the line for it, and then the guardrail or the handrail also meet at one point, and this goes down and this goes up. If you make this detail properly and make the stair here one before the other, or before or after the other, the starting of that is before the end of this, or after it, it will fix itself. But one of the good way to look at this is try to draft this in AutoCAD. If you draft it in AutoCAD and make that step, this step that I'm standing on, either a little bit 30 centimeters below, or 30 behind, or 30 centimeters after the last step here, it will fix itself. You see that it's going to meet in one point. Given that you are maintaining the same dimension of that, so that the dimension here and the dimension there and the dimension there are the same, they will meet in one point and maintain the same dimension for you. So that is something also that becomes noisy if you do not maintain this well. And you will see also, instead of having also the elbow here, you will see elbows below the stair, and that is common in our building. If you go also to the level between the step, the studio area and our level here in the offices, you will see that lots of problems happening. Structurally it will fine, architecturally it will fine, but it becomes noisy because it's not going to be beautifully connected to each other. Okay. I think the last thing that we also want to discuss is the annotation, so that you can go to annotate, and you have here thread number, so that you can just start here. Do not do it in the middle. Try to do it close to one of the sides like this. If you go here, it will count the stairs for you, and then you come here, it will count the stairs for you. So if you have here 20 steps, all of them are marked and tagged, and that is important in the working drawing to tell, because if there's a mistake, it will be shown by the number. So that if you have 19 steps and you're just drawing, you're showing 20 steps, it will raise a question where are the rest, so that you have to tag your stairs similar to that. And of course, this is showing as up, and then you have here the cut, because you're cutting in the level here. Another thing also that we might talk about is where is our cut. If you go to the level, okay, I want to go to my, let's see if that's there. Yes, here level, you have visibility, graphic, and then you have graphic display. This is how to show the hidden lines, another thing. But you have here an option for the, yes, view range. This will tell you here what is the cut plane. Of course, you're cutting in level 1, but what is the offset? If I decide to make this offset about 1.8, for instance, and then apply, I'll see that this line is shifted a little on top here, because all of this shown as an elevation, and it's not going to be the same. So that it tells you here what is the cut plane that you want to decide on. That's why when you're cutting, it shows you that the stairs here are shown above. That's why they are shown in dashed. So this is one of the, also the top and bottom is what is the range that you want to see, as well as the depth in clip. So that if you have here depth in clip, let me go to level 2 and see if this would work. Level 2 here, you see that this is shown as some of the floor above, below is shown as the door here, and this is shown. So we have the option, yes, here, look down, underlaying, so that you can look up, or you can just crop the view. You don't want to show anything that is below that level. So underlaying, you have range, level 1, or you say none, and then apply. If you hit apply here, everything that is below that level will be faded out. This is important, by the way, because sometimes you need to show some items that is below that second floor or the typical floor. But pay attention, if you are making that and you have a noisy space, or you have lots of details accumulated on top of each other, which is some of the concern that I shared with you. Do not always try to avoid the overlapping. So it becomes noisy, and people will struggle to extract information. So that sometimes you need it, sometimes you don't need it. So that this is now the ground, the second floor shown for me. One of the options also I want to just, I think I wanted to tell you about it. I think most of you know it, is the snap. This is important also, similar to the CAD. If you hit the snap, it will show you a list where you want to snap your cursor if you are drafting. And I want to do, for instance, anything. I want to do a snap. Save. It will snap to what I have here, so that this is something important also to understand if you want to do it. This is the mid of that point of this line, and it can snap you to the edges or the midpoints or the what point you want to snap to in order to accurate drawing.